Hello, my name is Jeremy Landry, and I am a consulting security engineer. And today I'll be covering the Next-Gen IPS deployment module. Our agenda consists of going over some planning, the components that make up a solution, and installation steps. Hopefully, by the end of this module, you will have learned how to identify and describe the ways in which a Next-Gen IPS system can be deployed, describe key architectural components and requirements for successful deployment, and list the main implementation steps involved in achieving the system's design goals. So in the planning phase, you want to make sure that you understand Firesite Management Console, or FMC, will need to be installed and configured with access to the management network. Sensor devices will need to be installed at all locations that you've determined need visibility and protection. So you're going to have to bring those online and connect them all or add them back into the FMC over the management network. Customers are going to need to have determined in advance what traffic segments they want to inspect and protect, and if they will be placing these sensors in line or will they be doing passive monitoring only. Interfaces will need to be allocated to each segment and configured. All devices should be licensed and configured from Firesite Management Center. And of course, you must cable all of your sensing interfaces. So some of the deployment locations and places where we see Next-Gen IPS deployed most commonly is at the network perimeter, usually at the internet edge, as you can see in the top left-hand corner of this diagram. Also, we'll see deployments in DMZ, considering the fact that the DMZ usually holds some pretty high important targets. We're gonna want to have extra visibility and control inside that area of the network. Some other locations that you can deploy are in the core, whether that's maybe the campus core or maybe even the data center, and critical network segments, which we'll go into here in a moment. So if you're deploying at the perimeter, obviously this allows you to block and monitor attacks coming in from external machines, namely the internet. And usually it's fairly simple to deploy this right behind the existing firewall or even integrated inside of an ASA using firepower services for ASA. In the DMZ, this is a partially trusted area where mostly web servers live. There's a high risk of compromising those assets, so deploying in DMZ is pretty attractive place to put the solution. And then a core deployment or data center deployment is gonna be a great place to detect east-west traffic between virtualized environments or detect attacks from inside the organization, and it's a good way to detect worm propagation and other inside attacks. Extranets, of course, if you have partners or suppliers or ecosystem partners that are going to be connecting in, you're going to want to have some level of visibility and control in between those networks and your own. Critical networks that we deal with the most are in-scope PCI e-commerce enclaves, as well as industrial control systems and SCADA networks. Usually these areas are of high value and target-rich environment where you'll want to actually be able to see what, if anything, out of the norm is going on in those environments. So we can actually be deployed inline or passively. Inline, of course, we can affect the traffic, and in the passive mode, we're going to have good visibility but no capability of actually affecting traffic, at least not as far as IPS on its own goes. Now we can go down to more sophisticated deployments where we can leverage a passive deployment alongside a solution like Identity Services Engine, where we can leverage what they call Fire and ICE integration, where we can actually have ICE do the control of the environment using the switches and the network infrastructure as the control plane, even though our detection method is in a passive mode. But that's a little bit outside the scope of this particular module. So starting with inline, when we're blocking or in monitoring mode inline, We could go between two devices at the edge usually. Most typical is between a switch and a firewall, or maybe the router and a switch. We use 2 ports on an IPS for inline mode. We'll set up an inline pair. We can do this in layer 2 or layer 3. We can be a bump in the wire, or we can have IP addresses on those interfaces and actually run in layer 3, also known as router or routed mode. Layer 2 is commonly referred to as transparent mode. Appliances may provide a fail-open or a fail-over capability for situations when a sensor loses power or a sensor suffers software failure. In the case of a 7000 and 8000 series firepower appliance, those have hardware bypass modules, or some of the copper fixed ports on those certain models will fail to wire, so that we don't lose connectivity. In the case of an ASA, we don't have that capability to fail to wire, except with the case of the ISA 3000. ISA 3000, or industrial security appliance, does have the capability to fail to wire. For passive deployments or monitor-only mode, we usually take off of a switch port in a span. We talked about that in a little more detail in the POV module, because that's typically the easiest way to do a evaluation or a POV is go off a span port. So a span port is nothing more than a special configuration on a switch port that allows you to mirror all the traffic from that port onto another port or another interface. We can also go off of a network tap. We'll talk about a little bit more detail about taps here in a moment. The good thing about going off a tap is all the heavy lifting is done by a third-party appliance off a network tap, such as a Gigamon. That device allows you to monitor a single segment without interrupting traffic flow, and it only utilizes 1 port on the IPS. The drawback, of course, is that we're passive only. We can't actually take effect on any traffic. So just to reiterate, device placement. Perimeter appliances usually sit behind a firewall. Chances are transparent inline mode is the easiest way to go. You turn on what's called link state propagation, so that the device north of the next-gen IPS is aware if the device south of the next-gen IPS should have an interface bounce or lose connectivity. We want to propagate the state of that link up to the other device. Alternatively, the firepower appliance can subsume basic firewall capabilities and run in a bridge or routed mode. These appliances, whether it's an 8000 or 7000 series, regardless, we can actually set them up as a router as well, and a virtual switch. We'll go into that a little more later. In the data center, appliances will often sit in a listen-only mode, so passive, maybe off of a trunk port, profiling all the data center traffic. Visibility is pretty important in the data center, yet because the stakes are high and there's a lot of high rate of traffic, we don't always go inline in the traffic. There's plenty of ways we can deploy inline in a data center, namely with ASAs we can use clustering. With firepower appliances we can stack several appliances together to gain higher throughput. Branch or wiring closets are pretty straightforward. We often want to be able to see threats in all these places, so these remote sites maybe. It's often expensive to deploy it everywhere. However, it's a pretty common option to enable firepower appliances to run maybe just the fire site discovery piece. So we have application visibility control. Maybe we don't need to do AMP and URL filtering and IPS at all those locations, but at least gain visibility to have context about all that traffic, adding it to the rest of the telemetry that's getting sent back to the FMC. So a single FMC or an HA pair of FMC systems are required to manage all aspects of firepower next-gen IPS deployment. There is no other management solution for firepower next-gen IPS. You need FMC. Inventory sensors, devices, and available interfaces. You're going to want to know how many interfaces you need for these deployments, so make sure that you know if you're going to be passive or inline. Inline deployments, you're going to need 2 interfaces. Passive, you're only going to need 1. Again, we go layer 2, transparent bridge, just a bump in the wire. That's the easiest way to go about it. You want to confirm that all your licensing is available and applied to the FMC and that they've been claimed by all the various sensors. And whoever's going to be installing this has access to get to the licensing if they need to shore up any licensing discrepancies. Make sure that you have the proper cables needed to make all the available connections. Something that some people forget sometimes is that whenever you have an inline segment, whenever you inject yourself in that topology, you're going to need 2 cables in place of where you previously only needed 1. As for passive deployments for span ports or other methods of feeding passive interfaces, make sure that that is all lined out and configured ahead of time. You don't want to be dealing with ill-configured span ports and wondering why you don't see traffic. So to install this, FMC is going to need to be installed and configured. You can do this on a VM, or you can do this with a hardware appliance. The sensors themselves, whether this is a firepower appliance or an ASA, will need to be installed at all the locations, brought up online, and connected, and added to the Firesite Management Center. More common than you would think, firepower appliances especially, either the person deploying them or the person helping out with the deployment will assume that the device is turned on just because it has lights on the front of it. It is not always the case, and if you're not getting traffic or you're not able to connect to the device, just check the front panel and make sure that the power button is green, not just amber. We want to make sure that the device is turned on. Believe it or not, this is a common gotcha in deployments that I've seen with partners and individuals. The customer is also going to need to determine what traffic they want to inspect and protect. If they're going to be placing a sensor in line, or will they be doing passive monitoring? If we're going to do passive, make sure that the span is set up according to which VLANs they want to inspect, etc. Interfaces are going to need to be allocated to each segment and configured ahead of time. All devices should be licensed and configured ahead of time, and the cabling needs to all be figured out ahead of time. So some of the deployment topologies that you're going to run into, one of the really easy ones is this tap deployment. Deploying multiple sensing interfaces on a managed device with a network tap is pretty straightforward. And this diagram kind of shows how a network tap is installed on a single high traffic network segment. In this case right here, where you see this diagram, the tap is going to be configured to transmit incoming and outgoing traffic through separate sensing interfaces. So when you do this, you can connect the multiple sensing interface adapter card on the managed device or the sensor to the tap, and the managed device is going to be able to combine both directions of traffic into a single data stream so that it can be analyzed. Also note there at the bottom that with a single optical tap, with a gigabit optical tap, as shown here, both sets of sensing interfaces on the managed device or the sensor are going to be used by the connectors from the tap. So when we talk about firepower services for ASA, the firepower module, for instance, on a 5585 is a separate piece of hardware sitting in the top slot of the chassis. Important call out on this slide, you must physically cable the management interface to an ASA interface. They are separate management interfaces. This is an example in routed mode how that would be done. Also have examples for transparent mode, which we'll show here in a moment. For mid-range ASAs, so anything that's not an ASA 5585. So these models are all going to run the ASA firepower module in a software module, namely a solid-state drive. And the ASA firepower module shares the management interface. And this could be 00 or 11, depending on which model ASA we're talking about. It's important to know that they do share the management interface with the underlying ASA. All management traffic to and from the firepower module must enter and exit that management interface. That module, the ASA firepower module, it absolutely needs internet access. It's going to need internet access to pull down all of its updates and all of its rules. and to do any cloud lookups for any kind of AMP malware lookup. Management traffic, rather, cannot pass through the ASA over the backplane. Therefore, again, you need to physically cable the management interface to an ASA interface to reach the internet. Here's a depiction of that when we do have an inside router. Here, the ASA5585X in transparent mode. So similarly, the way we discussed a moment ago in routed mode, the same is true for transparent mode, and this is what the cabling would look like. Make sure you connect that management module interface 10 to have an IP address on the same network as management 00. If you're not getting updates, chances are likely you've cabled this wrong or set up the interfaces incorrectly. You'll know real quick. If you do not use an inside router, you can manage the ASA over the inside interface using the bridge virtual interface IP address of the ASA. You don't have to use management 0 interface. So mid-range appliances in transparent mode. These models are going to run firepower modules as a software module. Again, all management traffic to and from the ASA still has to enter and exit through the management interface. Here's a topology diagram to show how that works when you have an inside router. If you don't have an inside router, if you're not going to use that, you can also manage it, again, using the BVI IP address of the underlying ASA. Notice at the bottom, no ASA IP address, because you're just going to use the inside interface's IP address to manage the ASA. You're going to use the firepower's IP address to manage the firepower module. So resources. This top link here is basically a link directly to 7000, 8000 series device deployments. It's where many of the diagrams from this presentation were borrowed from. The bottom link is a link to the entire documentation roadmap for all things firepower, whether that is an ASA or a firepower appliance, standalone appliance. It covers deployment of all these, configuration of all of these pieces of the solution, as well as configuration of things like user agent, etc. So in summary, now that we're at the end of this module, you should be able to identify and describe the different ways the next-gen IPS system can be deployed, understand the key architectural components and requirements for successful deployment, and understand the main implementation steps involved in achieving the system's design goals. So thank you for your time.